वेलकम टू वेदादी क्लासेस। वेदादी क्लासेस में आपका स्वागत है। टुडे वी विल डिस्कस अबाउट द आइसोमेरिज्म ऑफ क्लास 11th ऑर्गेनिक केमिस्ट्री, सम बेसिक प्रिंसिपल एंड टेक्निक्स. So isomerism is what? Let's start with the term isomerism. Iso means same. Merism means structure. If two or more than two compounds having the same molecular formula, if two or more than two compounds have same molecular formula but different in a structural formula. Now, so if the structure formula is different, then what will happen? Sometimes structure formula also have been seen same, approximately same in the case of stereo isomerism, which we will discuss later on. So if the molecular formula is the same, structure formula are different, so they are known as the isomers. So what happens if they are the isomers? So they have a different chemical and physical properties. So but same molecular formula they will have. So accordingly, isomerism of two types. One is known as a structural isomerism, and second is known as stereoisomerism. Okay, a structural isomerism is basically what is structural isomerism? Molecular formula is the same and a structure formula is the different. So this is known as a structural isomerism. How many types of this structural isomerism? So we have 6 types basically. First is the chain isomerism. Second is position isomerism. Third is functional isomerism. Fourth is metamerism. Fifth is tautomerism. And sixth is ring chain isomerism. So how many structural isomerism we have? We have 6 one: chain, position, functional, metamerism, tautomerism, ring chain isomerism. Stereoisomerism is what? Here the molecular formula is the same, a structure formula it also approximately same, but where the difference? So difference in space arrangement. So that's why it is known as stereoisomerism. Stereoisomerism is further of two types. One is conformational isomerism, and second is configurational. Configurational isomerism is further of two types. One is known as geometrical, and the other is known as optical isomerism. So how many types we have? So we have 2 one: conformational and configurational. So geometrical isomerism and optical isomerism. So we will study one by one. So first one we have to study about the chain isomerism. So what's about the chain isomerism? Chain isomerism. Again, since it is a structural isomerism, so its molecular formula will be same. A structural formula will be different. Why it will different? So different due to chain. So that's why it is known as chain isomerism. Now I can give you some example. Have a look here. Is a 1, 2, 3, 4, 5 carbon. So 5 carbon is pentane. So if the pentane is just like this, if you can put the hydrogen over here, no worry. So just like this, put the hydrogen over here. So this is your pentane, and this is the straight chain. So this is normal pentane, N-pentane. N-pentane. If there will be a branching of carbon from any middle of carbon, so like here like this, so this is your isopentane. This is known as isopentane. And if we have two sides branching from the middle carbon, so this is the middle carbon, the two side branching, so this is known as neopentane. Neopentane. So this is chain isomerism. So you can find out anyone if they have given you. Now we'll discuss about the position isomerism. Second one is the position isomerism. Position isomerism. So what's about the position isomerism? So again, since it is a part of structural isomerism, then molecular formula will be same. A structure formula, it will be different. Why it will different? So it will be different due to different position of same functional group. Have a look here. I just like to give some example. Like we have CH3, CH2, 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 CH2OH. So this is what? This is pentane all, pentane 1 all, or simply we write pentane all. Now when you write here just like CH3, CH2, CH2, 1, 2, 3, 4, 5, so CH, OH and CH3, then this is known as the pentane 2 all. Pentane second position, and second position OH is the second position, so we will say pentane 2 all. Now we can make one more structure of pentane. So CH3, CH2, CH, OH, 3, 4 and 5. So its name will be pentane 3 all. So this is what? This is the example of position isomerism. Why? Because the same functional group have taken the different position at first position, second position, third position respectively in the different molecules. So these three are the position isomers because they have same molecular formula, same structure formula. Same molecular formula, and the structure formula is different due to the position of same functional group. Now I just like to give you some more example, like we have beat 1, 2, 3, 4, like this is CH2, CH, CH2, CH3. This is now the butene, but1ene, or simply butene. And if you write just like this, CH3, CH double bond, CH, CH3, so this is known as a but2ene. So this is but2ene is what is the isomer of but1ene. So there is a change in position from 1 to 2. So this is the type of position isomerism. You can take any example in which the functional group changes its position are known as position isomerism. Now have a look here. Now the third one, the most important one, is the functional isomerism. Functional isomerism. So what's about the functional isomerism? So since it is also the part of a structure isomerism, so molecular formula will be same. A structure formula, it will be different again. Why it will different? Then it will different this time due to different functional group. Now this time not the position of same functional group will be different. Here we will use the different functional group. So I just like to give you some example, like have a look here. So this is what, this is 1 1 1 1 1. So this is what, ethanol. Simply we say ethanol. And when you just take the example of this one, so this is what, so this is your methoxymethane. This is what, methoxymethane. So let's check its molecular formula. So first check the molecular formula of ethanol. So it have 2 carbon, how many hydrogen? Then it have 6 hydrogen, and how many oxygen? 1 oxygen. Now, so this is ethanol is alcohol, so this is the alcohol. Now methoxymethane, this is ether. And what's about the molecular formula? So it have also 2 carbon, 6 hydrogen, and 1 oxygen. So this is your ether. Now have a look here. This is the alcohol, this is the ether, having same molecular formula, but functional groups are different, so they will have the different physical and chemical properties, isn't it? So now, but this is a very remarkable thing. I'm just going to tell you that this functional isomerism only possible between some fixed functional groups. Like have a look here. Like functional isomerism possible in alcohol and ether, aldehyde and ketone, carboxylic acid and ester, amines we have 1 degree, 2 degree, 3 degree amines, cyanide, isocyanide, cyanide, isocyanide, nitronitrite, nitrite, and anything else. So this is these are the pairs in which there are some amide and oximes too. So have a look here. So functional isomerism is possible between alcohol and ether. It is not possible between alcohol and ketone and carboxylic acid, or the ketone and ether. It is not possible between the carboxylic acid and the amines, or the carboxylic acid and aldehyde. So it is only possible between these pair, either these in the form of these pair, like alcohol, ether, carboxylic acid, ester, aldehyde, ketone, amines, cyanide, isocyanide, nitrite, amide, and oxide. So have a look here. I just like to give you some example. One more thing. It is also possible in alkenes too. So alkenes and alkynes, dienes, it is also possible between dienes, alkenes, and alkynes. We'll discuss about this. What is these are? So let's start with the first. First, we have given the example of alcohol in ether. I have given you the example of C2H5OH and CH3OCH3. Now you have to make a functional isomerism between aldehyde and ketone. So for the ketone, at least 3 carbon is required. So you have also to take 3 carbons aldehyde. So 3 carbon aldehyde is CH3, CH2, C double bond OH. Okay, and the 3 carbon ketone is CH3, C double bond O, CH3. So 3 carbon aldehyde is propanol, and 3 carbon ketone is acetone or propanone or propanone. So now have a look here. We will check the molecular formula. So both have the same. It will have the same molecular formula. Have a look here. Carbon is how? 1, 2, 3 carbon, 3 carbon in all both, and hydrogen is 6 hydrogen over here, and 1 oxygen. Now in both the cases, number of carbon, number of hydrogen, number of oxygen is same. So the molecular formula is the same, but one have the functional group aldehyde, other have the functional group of ketone. So these are the example of functional isomerism. Let's talk about the other one. So other one is which one? Other one is between carboxylic acid and ester. Carboxylic acid and ester. For the ester, I'll take at least 3 carbon. So CH3, CH2, C double bond O, OH. Now, and ester is what? Ester we can take CH3, C double bond O, O, CH3. Now, what this compound is? So this is we can say this 3 carbon carboxylic acid, then propanoic acid, propanoic acid, and this is the 3 carbon ester. But how you just give the name? So I told you about the IPC nomenclature. In IPC nomenclature, so it will named as alkyl alkanoid. So alkyl is methyl. So here the methyl, and 2 carbon is here, then ethanoate. Now check the molecular formula again. So what's about the molecular formula of these 2 molecules? One is the carboxylic acid, other is the ester. So have a look at 1, 2, 3 carbon in both the cases, and how many hydrogen? 3, 2, 5, 1, 6 hydrogen. And how many oxygen? 1 oxygen is over here. In this case, again 2 carbon, 6 hydrogen, 3 carbon, 6 hydrogen, and 2 oxygen. 2 oxygen is over here. In both the cases, 2 oxygen is here. So molecular formula is the same, structure formula is different. Why? Because this is carboxylic acid and this is ester. Now I just like to give the example of amines. Amines is what? Amines, as you know, is the 3 type: 1 degree, 2 degree, 3 degree amines. So let's give the example of, just take the example of CH3, CH2, 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 NH2. This is the 1 degree amine. The NH2 is the 1 degree amine. So its name is what? 1, 2, 3, 4, butaneamine. Butaneamine. Okay. Now, if you take the example of CH3, how many carbon? 4 carbon. 4 carbons, 2 degree amine we required. So we just put CH3, CH2, CH3, CH2. We can give some other combination too, accordingly. So we can also make like CH3 over here, and CH3, CH2, CH2 over here. So this is also will be same. Same is what? Means both will be the 2 degree amines, but the name is the different, the structure is also different. So as in this case, this is known as N-ethyl, what do you write the name? N-ethyl ethanamine, and in this case N-methyl propanamine. So both are this is the 2 degree. Now we can also give the example of 3 degree having 4 carbon. So it's a CH3, like CH3, and put C2H5 over here. So this is what this comes just like this, N over here. So it is NN dimethyl ethanamine. So this is what? 3 degree amine. Now check the molecular formula in all the cases. So if we check the molecular formula, then it will have 1, 2, 3, 4 carbon, and how many hydrogen? 2, 4, 6, 8, 10, 11 hydrogen, and how many nitrogen? 1 nitrogen is over here. In this case, again 1, 2, 3, 4 hydrogen, and 3, 3, 6, 6, 4, 10, 10, 1, 11, 4 carbon, 11 hydrogen, and 1 nitrogen. In this case, and in this case is also 2, 3, 4 carbon, 3, 3, 6, 6, 5, 11 hydrogen, and 1 nitrogen. So all have the same molecular formula. All amines have the same molecular formula, but the different structure formula. Why? Because they are 1 degree, 2 degree, 3 degree amines. Their functional group are different. Now have a look here. Now amines we did it. Now cyanide and isocyanide. So you can give one example of cyanide and isocyanide. So cyanide is just simply we just take the CH3 CH2 C triple bond N. So what do you say this 3 carbon cyanide? This is known as the either we can say ethyl cyanide or propane nitrile. Propane nitrile or ethyl cyanide. Ethyl cyanide. Now we take the isocyanide like CH3 CH2 N double bond covalent bond C. So this is also 3 carbon, but this time we will say ethane isonitrile nitrile. So now check the molecular formula again. So how many carbon is there? So 1 2 3 carbon over here, and how many hydrogen? 3 to 5 hydrogen is here, and how many nitrogen? 1 nitrogen. In both the cases same thing is coming. So molecular formula same, structure is different. Why? They have different functional group. Now similarly we can take the example of nitro and nitrite. CH3 N double bond coordinate bond O. So this is the nitromethane. This is your nitromethane. And when you take the example of CH3 O N double bond O, so this is what? Methyl nitrite. Methyl nitrite. Again same molecular formula. 1 carbon, 3 hydrogen, 1 nitrogen, 2 oxygen, just like this. So this is what this is the molecular formula of nitro and nitrite. So this is the functional isomerism. Now we can also discuss about if the double bond is present over there, or also amide is present over there. Amide and between amide and oxime have a look here. Amide, like we can I can give you some example of the amide. So like amide is like CH3 CH2 C double bond O NH2. So how many carbon? 3 carbon. Then it's the propanamide. It is known as propanamide. Okay, now again if you take the oxime, so oxime is just like this: CH3 CH2 CH double bond NOH. So this is known as propanal oxime. Propanal oxime. Now in both the cases, again when we check the molecular formula, so if you check the molecular formula, what it comes, so it will be how many carbon? 2 carbon is over here. Hydrogen is 3 to 5 to 7 hydrogen is over here. 1 to 3 carbon, 3 carbon is over here. 7 hydrogen and 1 nitrogen and 1 oxygen. Okay, in the both cases 1 to 3 carbon, or 3 to 5 6 7 hydrogen, 1 nitrogen, 1 oxygen. So these are also the what functional isomerism. Now have a look here. If they are dienes and alkynes, so dienes is what? Diene means 2 double bond. Alkynes is what? Alkynes having triple bond. So just take first example of the dienes and alkynes, then we'll just think about allenes. Allene is what? Allene is also the having diene, but consecutive double bond should be present. So that's the have a look. I just like to give some example like CH2 double bond CH double bond CH2. So there is a 2 double bond, but not consecutive. If it become consecutive, then it will known as this is the dienes. If it will consecutive, then it will be what? It is just like this. If it is just like this, CH3, so it is known as allenes. So this is known the allene. And if the triple bond is over here, like we can give like CH3 CH2 C triple bond CH. So have a look. This is the alkynes, this is the diene, this is the allene, and this is the alkyne having triple bond. So this is if you want to give the IPC name. So IPC name is 1, 2, 3, 4. 4 is but 1, 3 diene. And this case 1, 2, 3, 4 but 1, 2 diene, 1, 2 diene. And in this case but 1 wine or butine. Simply, but it can also, you can take the example of CH3, C triple bond, CH3 na. So this is what but 2 wine, So in all the cases, what do you observe? Molecular formula. Let's check the molecular formula. So how many carbon? 1, 2, 3, 4. 4 carbon is over here. And how many hydrogen? 2, 4, 5, 6. 6 hydrogen is over here. So C4H6. In all the cases, number of carbon, number of hydrogen the same, but the molecular formula here, the molecular formula is the same. The structure is different because this is the dienes only, this is the allenes, this is alkynes. So this is all about the functional isomerism. Now we'll just discuss about the next one, and the next one is known as metamerism. Fourth one, we have metamerism. So what's about the metamerism? So molecular formula, since it is a structural isomerism, so molecular formula is the same. A structural formula, obviously it will be different. Why it is different? Different due to different distribution of this is a different distribution of same functional group, different distribution of alkyl group on both side of same functional group. What the meaning of this? Have a look here. Suppose we have 5 rupees, and the 5 rupees can be distributed in small notes like 2 plus 2 plus 1, or it can be distributed like if it is, suppose it is a number, not the note, you will get confused. So it's a 1 plus 1 plus 1 plus 2, or either we can write here the 1 plus 1, 2, 3, 4 and 5, like this. Suppose there's notes, then it's same thing. So there is 3 ways to find out the 5 previous coins, either 2 plus 2 plus 2 plus 1, or means all are the same. Now, in the similar way, what I want to state, suppose I am giving the example of this one. Here we have taken the CH3, CH2, O, CH2, CH3. What the name of this one? So this is the name is ethoxyethane. Now if you take like CH3O, CH2, 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 CH3, so this is methoxybutane. Butane. Now have a look here. This is your methoxybutane. So have a look. In first case, oxygen here, the ether, this is the ether. This side 2 carbon, this side 2 carbon, 2 to 4. Acha, I've committed mistake over here because we have to take 4 carbon only. So just remove 1 CH2 over here. So this is methoxypropane, suppose. Propane. Okay, now. So this is 2 carbon, total 4. Now this side 1 and 3. Now 4 carbon. Now, so in the both the cases, molecular formula is the same. A structure is becoming different. Why? Because both side the distribution of alkyl group is a different. In first case 2 carbon 2 alkyl group, whereas in the second one the one alkyl group and 3 carbon alkyl group is there. So this is the metamerism. Metamerism is only possible between those which have terminals. Terminals means it is possible between ethers, it is possible between ketone, it is possible between ester, like this, where both the terminals, both the end is open. So metamerism is possible in those cases only. It is not possible everywhere. So it is possible in those cases only. So I just like to give you some example. I have given the example of ether. Let's talk about the example of ketone. Like we have the CH3, C double bond O, CH, CH2, CH3. So how many carbon? So we can say this is the butane, but 2 on, yeah, butane 2 on. Now, but if it is like CH3, okay, now just make 1, 2, 3, 4 now. So you just make one more carbon over here, like CH3, CH2, 5 carbon. So pent 3 on, pent 3 on. Now you can write it just like CH3, C double bond O, 2, 3, 4 and 5. So now in this case is what? So this is again pent 2 on. This is pent 2 on. So in this case, distribution of alkyl number of carbon of the alkyl group is 2. In this case is the 1 and 3. Now, so now we can also give the example of ester. Ester having CH3, CH2, C double bond O, C2, H5, or we can write here the CH3, CH2, CH2, C double bond O, CH3. Now 2, 3, 4, 5, 1, 2, 3, 4, 5. So this is the name of this one is ethyl, and 1, 2, 3 propanoate, and this one is methyl propanoate, So now both are the ester, and in this case this is the functional group ester 1, and distribution of the number of carbons in alkyl group is 2 and 2, 4. In this case is 3 and 1, 4. So these are known as the metamerism. Now position isomerism, we will say this is also looking like position isomerism. Yes, it looks like position isomerism. So basically all the metamerisms are position isomers, but all the position isomers is not metamers. So all the metamerism or metamers are position isomers, but all the position isomers are not metamers or metamerism. We do not show metamerism. Like this also looks like the position isomerism 3 on, 2 on, like this one. But it's like if you take the example of CH3, CH2, CH2OH and CH3, CHOH, CH3. So this is the propane 1 all, and this is propane 2 all. It is the position isomerism, but this is not the metamerism. So you should keep in mind. Now let's move to the next one. Next one is ring chain isomerism or tautomerism. Let's do the first tautomerism. Tautomerism is what? Tautomerism is a special kind. This is a type of functional isomers, or exist in dynamic equilibrium with each other. So tautomerism basically what you say, tautomerism basically it's a type of what you write type of functional isomerism, functional isomerism. But the thing is what these are those isomers which exist in dynamic equilibrium. So those functional isomers which exist in dynamic equilibrium. So what the meaning of this? Let's see. So tautomers is of basically two type. So first we discuss about the type, then we'll discuss about the examples. So one is known as dyad systems, and other is known as triad system. Nah? So what is the dyad system? What is the triad system? Let's think about this. Dyad system is what? Dyad system is just like this. Dyad system, we can say there is a type of isomerism where 1 and 2 migration of proton take place. Migration of proton is what? Proton we simply say H plus. So I just like to give you the example like CS3 C triple bond N. Now when it forms CS3 N double bond coordinate bond C, so what happens in this case? Take the example of simple example, it will more convenient to make you understand, like HCN and HNC. Now so this is hydrogen cyanide, and this is hydrogen isocyanide, Now what's happening over here? This hydrogen means when it comes in the form of H plus, just transfer. This is the one carbon. This is the polyvalent. Basically, we can say this is the polyvalent atom, having valency more than 1. So hydrogen will get migrate from carbon to nitrogen, and it will form isocyanide. So this is the migration from 1 to 2. So this is the 1-2 migration of proton. So this is the dyad system. In triad system, what happens? In triad system, basically 1-3 migration take place. Triad system, and this is also take place between polyvalent atoms. So I can give you the example. Basically, this is the keto-enol form. It's a very simple example of the keto-enol form. What the keto or what the enol form? Have a look here. Keto means all molecules having C double bond O is known as the keto. Enol means having double bond and OH. That's the enol. So let's I just like to give you the example of acetaldehyde, CS3 C double bond OH. What happens in this case? Wait a second. So oxygen is more electronegative, then it will develop a negative charge over here. The positive charge will develop over here. To compensate the deficiency of electron, this bond breaks and it forms a double bond over here, and this hydrogen becomes plus charge. So this is the first atom, second and third atom. So H plus will transfer from first to third. So 1-3 migration take place. So what will happen? Have a look here. So this hydrogen will come over here because this is plus charge, this is minus charge, and this becomes single bond because the electron have transferred from here. So it will be, structure will be just like this, CH2. Now the double bond will be here, double bond over here. This oxygen have this hydrogen H over here, and so now this hydrogen is already present. So this is the structure. Now have a look at, since this structure have CO, then it is the keto form. Now this structure have double bond En and OH means all, so in all, so this is the ketoenol form. This is what? This is known the ketoenol form. And ketoenol form have, this is one carbon, first atom, second atom, third atom, and proton is getting transferred from 1 to third. So this is known as a 1,3 migration of proton. We also say this is 1,3 migration of proton. So this is the triad system. This is a type of triad system. I can give you some more example. If let's see the example of ketone, acetone, like CH3, C double bond over here, and CH3. Now, so this is the keto form. Now, how it will get converted into enol form? Then have a look here. Oxygen is electronegative, minus, and to compensate this will develop plus charge. To compensate, double bond will come here, it will develop a plus charge over here. H will get transferred over here. So it will be, the structure will be just like this. This is the CH2, and double bond over here, and the COH, and it will remain same CH3. It will not change. Only transfer of one proton will take place from here. Now it can also take place from here. It can also, because this is also have the alpha hydrogen, alpha carbon, alpha hydrogen. So it can take place over here. So this is the keto form, and this is what? Nitro form. Enol form. Enol, double bond, OH, enol form. So this is about the tautomerism. There is some more we have, like nitroacid, like we have some. I just like to give more example of tautomerism. This is first, that was the ketoenol form. This is the nitro tautomerism. Nitro tautomerism, in which 1 degree and 2 degree nitroalkanes having alpha hydrogen shows such type of tautomerism. Have a look here. CH3, N double bond, O and O minus. This is the nitro form. Nitro form is to develop plus charge, so it is the nitro form. And it will get converted into CH2, double bond, N plus, this is the OH, and this will be remain O minus. So this is what AC form. Simply you say nitro Si form. So nitro form and AC form. So nitro Si form. So what's happening in this case? In this case, like CH3, I just like to explain this. Again, CH3 is over here. CH3 over here. So compensate this one. This bond breaks and forms a double bond over here, and this will come over here. So to compensate this will form OH over here, and double bond will form over here. So this is the nitro form, and this is Si form. Now some more example I have of the tautomerism type. Nitroso-oxymenor system. What you say? Nitroso-oxymino system. So what is this one? So this is the example of CH3, CH and CH2, N double bond O. So this is known as the nitroso-ethane. Nitroso-ethane, and when it form just like this, how many is the first atom, second atom, third, 1,3 migration will take place, and so it will form a double bond of this is the negative charge, and to compensate this hydrogen will form a double bond over here, so it will be CH3 CH double bond, and this will be N, and this oxygen will have OH, this oxygen will have O, and this hydrogen will come over here, so it will be NOH. So this is what ethanol oxime. So this is what, this is oxyamine form. So this is the nitroso, what is a, this is a nitroso, and this oxymino form na. So this is, now one is a more we have, like we can give some more example over here. Imine and inamine. So imine is what? So such type of amine having double bond NH. So this is known as imine. So this is the CH H and CH double bond NH. So this is imine, IMINE. So this is known as prop 1 imine. Nah? So now what happens? Same thing happens over here. So double bond will come over here. This is minus, so plus, to compensate this double bond. So this H plus will get combined with this one. So it will form NH2. So the structure will be what? It will be CH3 CH double bond over here, CH, or this will become NH2. So it will in for double bond, or amine for NH2. So inamine. So it is how it is converted, imine to inamine. So these are the examples of what tautomerism. Now the last one is ring chain isomerism. So what's about the ring chain isomerism? So in ring chain isomerism, again the molecular formula is same. Structure formula is a different. Why it is a different? Due to ring and chain. Now, so have a look here. Like this is cyclopropane, and this is CH2, just like this. So this is cyclopropane, and propene is what? 1 2 3 double bond CH2 CH CH3. Have a look at propene. So cyclopropane and propene have same molecular formula. Have a look here. How many carbon? 3 carbon. How many hydrogen? 6 hydrogen. So this is known as ring. This is the ring form, cyclopropane, and propane is in chain form. So this is known as ring chain isomers. Now all cycloalkane are isomers, ring chain isomers with alkene, and cycloalkyne will ring chain isomerism with cycloalkene. Here is cycloalkene will be ring chain isomerism with alkyne. Now have a look here. So I can also give the example, like this is suppose a double bond over here. So this is CH, and this is CH2. So this is cyclopropene, and so if you put over here triple bond over here, so this is cyclopropine. This is propine. This is propine, YNE. So have a look here. Molecular, again check the molecular formula. So molecular formula is the same, C3H4, and again in this case C3H4. So this is the ring chain isomerism. So today we have finished the structural isomerism. In next time we will discuss about the stereoisomerism. Till then, take care. Bye.